Okay, class, can we start? Is this audible to you?
Yes, ma'am.
Yes, ma'am.
All right. So in the last class, we had completed till electric field. We had started with what is meant by electric field. So right now also we were discussing that electric field is basically the space around a charge where electrical phenomena like forces can be experienced. This charge generates a certain space around itself that is known as the electric field. Now, we didn't calculate what is the formula of electric field or what is the intensity. See, electric field intensity basically means what? If I have this charge, capital Q, this is what? This is my source charge. Again, reminding, source charge was what? Source charge is the charge that generates the electric field. So this is the source charge. And I have brought another charge, small q, with it. Now this charge is there to know what is the nature of my source charge. So this is known as the test charge. This is known as the test charge. So the source charge will be generating its electric field. The test charge will come in the vicinity of the source charge and we will be experiencing electric force. And this will prove us that source charge has a certain space around itself that is called as the electric field. Now, electric field, whatever electric force is experienced by this test charge, whatever is the electric force that is experienced by this test charge, we call it as electric field. See, I'll write it down so that it becomes clear. Electric force, the electric force experienced, by the test charge Q. This is the test charge Q experienced by the test charge Q. But field is what? Field is of capital Q or small q?
Small q.
Capital.
Capital Q. See, electric force has been generated on this, but the electric field is of capital Q. No, that's why we are calling it. That's why we are calling it as the source charge. This is experiencing force. As soon as we are bringing it closer in the proximity of capital Q, we are able to experience electric force. So the electric field is of capital Q. So electric force experienced by test charge Q due to the field of capital Q. This is the source charge. We just call it as the source charge because this generates your electric field. Otherwise, this is simply your charge, simple charge that is having its certain field. Now see, relation between electric field and electric force is what? What did I tell you? Electric field is basically all the electric force that is experienced by this test charge. So see, I can give a relation in this manner. Electric field is basically what? Electric field is force experienced by what? The test charge. So this becomes your first formula of electric field. Electric force experienced by the test charge. Okay, we can write it in one more manner, which usually is not written, but we can write it in this manner. Limit q, small q tends to 0, and then we can write f by q. Now see, what is the significance of putting this limit q tends to 0? What is the significance of putting this limit q tends to 0? See, if you make whatever force is exerted on capital Q. See, capital Q is generating force on small q, but small q is also a charge. It will also be generating force on capital Q or not? Yes or no? Agreed or not?
Yes, ma'am.
If small q is the test charge, it will also be generating electric force. But we do not want the source charge to move. We want it to be static. So whatever force is generated by small q, if I limit that and make it almost equal to 0, so there won't be any force exerted on capital Q. So just to represent that, we put this limit q tends to 0. This shows that force exerted by small q, this is almost negligible. This is almost negligible. This is so small. So it means what? This means capital Q cannot move. Capital Q is now static. Capital Q is now not able to move. All right, so this is basically in this what you have to remember. Electric field is force per unit test charge. Electric field is F divided by Q. This formula will not only be used in this chapter, this will continue in your magnetic, still your magnetic. It will be utilized in your potential also. So this is the basis and the first formula of electric field, F by Q. Now regarding some things about electric field is a vector quantity. The way electric force is a vector quantity. This is a vector quantity. Okay, tell me one thing. If I write electric field as equal to force per unit charge, okay, now Rifat, you tell me. If I put Q as 1 Coulomb, okay, vector quantity I'll discuss, Fahad. Before moving on to this point, Rifat, you tell me, if I put charge as plus 1 Coulomb, what will be the relation between electric field and force? Just put Q as 1 Coulomb. What are you getting? What is the answer you are getting? Just try. Electric field is equal to force. Correct, you're right. See, if I put Q as 1, it means what? Electric field will directly be equal to electric force. So we get another definition of electric field. See, electric field is the basis of your chapter. So you have to understand it in detail. Electric field is what? You can get one more definition from this. Electric field is the force. At any point, if you have to calculate, this is the force experienced by what? By a unit positive test charge. See, as soon as I keep the value of small q as plus 1 Coulomb, I get the electric field equal to the electric force. So electric field is force experienced by unit positive test charge. This is another definition of electric field. Now, coming back to vectors and scalar quantities, let's just quickly revise this. Can any of you tell me, apart from Fahad, can anyone tell me what is a vector quantity? Anyone who remembers it?
It has both magnitude and direction.
Perfect, Samia, perfect. See, vector quantities, physical quantities are divided into scalar quantities and vector quantities. See, Fahad, understand this. Scalar quantities have only the magnitude. It means if you have scalar quantities, like when we'll deal with potential, we'll see it as a vector scalar quantity. They have no direction. You don't have to specify any direction. But as soon as you know that a quantity is a vector quantity, it gets associated with a magnitude as well as the direction. For example, if I talk about electric field, I'll be discussing what is the direction of electric field, don't worry. But it means electric field has a certain magnitude. For example, electric field's value is 4 Newton per Coulomb. Let's say electric field is this. This has a magnitude. Apart from this, electric field will be having a direction. Let's say if this is the charge plus, So its direction will be somewhat this. How we have to take out the direction, that we'll discuss it. But the basis of a vector quantity is that it has a magnitude, it has a direction. And since it has a direction, we have to solve it using vector laws. Vector laws, I hope you all remember. I'll also discuss the vector laws. Samya, that class was not able to arrange, no? Did you get any information about that class?
No, ma'am. I joined, but then it was not.
The meeting didn't start, no, because there wasn't any confirmation. I was also even worried about that. Fine, so Samya, I'll discuss it in the class only. The basic vectors, we'll discuss it here. So this is the force experienced by unit positive test charge. So electric field has what? It has a certain magnitude, it has a certain direction. Fahad, now is it clear what is the basic difference? All right, Fahad. So electric field is also a vector quantity. It means it has the magnitude, it has a direction. Now see, regarding the SI unit, electric field is basically force divided by charge. So yes, Yusuf, you tell me, what is the SI unit of force? Yes, Yusuf. SI unit of force. You must have done it in your previous class. SI unit of forces. Yes, Fad, you're right. Yusuf, what about you? Are you able to listen? Is it audible to you, Yusuf? Just reply with a yes or no. So yes, the SI unit is Newton. The SI unit of force, this is Newton. And we have already discussed the SI unit of charge is what? Coulomb. So SI unit of electric field becomes what? Newton per Coulomb. This is the SI unit. Okay, Yusuf, fine. Yes, Newton is the correct answer. One more unit is there, that is volt per meter. But volt per meter is not of your concern when we are dealing with chapter 1. When we'll move into potential and capacitance, we'll see how this unit comes with the help of which formula. Right now, you can use Newton per coulomb, but for your knowledge, you should remember that the SI unit is also volt per meter. So this is what is meant by electric field. Any doubts
Okay, ma'am. No, ma'am.
clear to all of you?
Yes.
All right. So now start writing from here. If you have any doubts, you can even text me or you can unmute yourself. I'll be slowly scrolling it down so you can keep on writing it in your registers. Which line? Which electric field is the force experienced by a unit positive test charge? See, Fahad, see, electric field is what? The formula of electric field is F divided by Q. This is what? This is force experienced per unit charge. Now, if this is the force experienced for a unit charge, let's see, if I put the value of Q as +1 Coulomb, if I take the unit positive charge, unit positive means what? Unit means 1, positive means the sign 1 plus. So if you put it in this formula, you will get what? Force divided by 1 because Q is 1. So electric field is directly equal to the force experienced. So electric field is basically the force experienced when we have +1 Coulomb. All right. Okay. Fine. When you all are done by the writing part, just text me done in the chat box. Then we'll move further. Then I'll know that you have written it down. Written? Rifat, Reem, and Samia have written. What about others? Fahad and Yusuf. Done? All right. So you're done. Now, see, if you have a point charge with you, let's say capital Q is your point charge. If I want to know what is the electric field for a point charge, so what will be the formula of it? See, for 2-point charges, what was the electric force? If you remember, we had done electric force was what? It was K Q1 Q2 divided by R square. What was this law? K Q1 Q2 by Coulomb's law. Correct. This was Coulomb's law. So see, electric field for a point charge. See the this is a very easy derivation of yours. Because what? Electric field is what? Electric field is force divided by test charge. Now, if you have two charges, this is the source charge with you, which is generating the electric field. And at a certain distance r, I'm calculating the electric field for the test charge. This is the source charge, which is the point charge. This is the source charge, which is the point charge. This is the source charge, which is the point charge. And this is my test charge. So we have discussed it a lot of times now that electric field is what? Basically the force experience for a unit positive test charge. Now, what is the force? One charge is capital Q, other charge is small q. Samya, we did it in the previous class only. You only tell us. According to Coulomb's law, how will I write this? One charge is capital Q, other charge is small q. Separation between them is small r. How will we write the Coulomb's law?
K capital Q
Capital Q,
small q
small q,
and r square.
divided by square. Very good, Samya. This is how you will be writing it. See, if you have electric force with you, can I get electric field? If I divide this whole term by small q, I'll get only electric field, no? So let me put the value of electric force in this. Electric force will be what? Electric field will be what? Electric force means K Q divided by r square divided by small q. In the formula that we have, F divided by Q. See, small q gets cancelled. Electric field is what? This is K Q divided by R squared. So this is the electric field's formula for a point charge. And it can be written as what? This can be written as Q by 4 pi epsilon naught R square. Why I'm able to write this? Because K is equal to 1 over 4 pi epsilon naught. So if you get questions, just put the value of K directly as 9 into 10 to the power 9. You can put the value as 9 into 10 to the power 9. You will get the answer. Now, as I've told you, this will give you the magnitude. Since this is a vector quantity, we require the direction. So the direction is very easy. The direction of this is very easy. Listen carefully. If you have a positive charge with you, just make a note point. After, I'll give you time to write it down. Don't write whenever I'm teaching. Otherwise, you won't be able to listen carefully. If it's a positive charge, if you have the positive charge, then electric field is directed away from the charge. Directed away from the charge. Means you have to move away from the charge if you have a positive charge. Just contrary to it, if you have a negative charge with you, move yourself towards that charge. Electric field is directed towards the negative charge that you have. This is the direction. Now, these both are the theoretical points. Let's see by example how we'll be able to write it. See, if I give you a charge plus 2 Coulomb and I give you this point A, you have to find out electric field at this point. Take the point, move away from the charge. See, if I move away from the charge, this is my charge. If I move away from the charge, this will be the direction of electric field. This will be the direction of electric field. If I give you this point, let's say this point is B. Electric field is what? Moving away from the charge. Move away from the charge directly. This is the electric field. If I give you this point C, positive charge is there. Electric field you have to calculate. Move away from the charge. Moving away will lead you in this direction. If you have a point D, if you have this point D, you are asked to calculate the direction of electric field at this point. So how do you calculate the direction of electric field? Simply move away from the charge. By simply moving away from the charge, this will be the direction of electric field. These are the direction of electric fields that you have. So this is valid for a positive charge. This is an example that I have taken for a positive charge. Now, if I take a negative charge instead of this, if I take -2 coulombs, now one by one, all of you tell me, yes, Reem, I have given you a point A. Will the direction of electric field be towards the left or towards the right? We move towards the charge for negative. Yes, Reem.
What's the right, left?
Towards the left. Perfect. Because we are moving where? We are moving towards the charge. We are moving towards the charge. So this will be the direction of electric field. Yes, Fahad. Correct. Fahad, you tell me, is it right or left for point B that I have given to you? It's right. Perfect. It will be right because we are moving towards the charge for a negative point. Samya, you tell me, if I have given you this point C, what will be the direction?
Downwards.
Downwards. Perfect, perfect, Samya. Very good. This will be the direction towards the charge if I give you this point. Similarly, if you have a point D, yes, Rifat, what will be the direction?
Upward.
Upwards. Very good. A direction will be upwards. That's how you take out the direction of electric field. So, before just discussing the questions, just note down these points, then we'll do a numerical, how to apply this formula. So this is basically electric field for a point charge. Is it clear to all of you?
Yes, ma'am.
Yusuf, what about you? All right, Fahad. Okay, start noting it. See, the question says what? Test charge of 10 to the power minus 3 Coulomb is there. The force that it has experienced, this is 100 Newton. You have to calculate the electric field. So you have a direct relationship. Electric field is force divided by charge. Quickly calculate this and send me your answers. The calculation is very easy. You have the force, you have the charge. Just take the ratio and submit your answers. Samya, just check the sign of your power. Just check it once again. You're almost close to the answer. Rest of you also, please submit your answers quickly. Yes, only this formula, Reem. With the help of this formula, you will get the answer. Just put in the values in this formula. See what you are getting. Okay, let's discuss it. Okay, Fahad, I have seen your answers. Yes, Samya, now your answer is correct. The correct answer is 10 raised to the power 5. See, all of you, electric field is what? This is force divided by charge. Now, force is given to you what? This is 10 to the power 2 newtons, means 100 Newton. Charge is what? Charge is given 10 to the power minus 3 Coulomb. See, if you put it in the formula, force is 10 to the power 2, charge is 10 to the power minus 3. This charge 10 to the power minus 3, this will go in the numerator and it will become 10 to the power positive 3. So 10 to the power 2 multiplied by 10 to the power positive 3. What is it? This is 10 to the power positive 5. This is your answer. Final field. Test charge. This is the unit is Newton per Coulomb. All right. So all those who are not able to do, just note down the solution. We'll do one more question based on electric field. See, it says that a point charge 10 Coulomb is kept at the origin. What is the electric field? What is the electric field at the point A? The A point is what? This is located at 3, 0, 0. It means which axis? If this is given x-axis, correct. This is x-axis. So see, this is your charge 10 Coulomb at the origin. This is located at 3 meters. We are calculating. This is some point A. We are calculating the electric field at this point. Now see, electric field is what? K Q divided by R square. This is what we had concluded, no? If a point charge is kept. See, value of K. Can any one of you tell me what is the value of K that we have to consider? We have just done it. Constant's value. Yes, Fahad. Fahad is right. So only Fahad knows. 1 over 4 pi epsilon naught. What is that term if you put in the values? Fahad is right. It is 9 into 10 to the power 9. See, remember, whenever you get it, value of K will always be 9 into 10 to the power 9. Charge is given as 10 Coulomb. R square means square of 3. That is 9. So this gives 10 to the power 10. Now see, is the answer sufficient? Writing the magnitude will not suffice our answer. Reason? Because electric field, this is a vector quantity. It requires the magnitude as well as the direction. So see, if this is your positive charge, should I move towards the charge? Means left or right?
Right.
Right hand side. Yes, Samya, it will be right hand side. Reason being, we are moving away from the charge. This will be the direction of electric field. Now, can any one of you tell me again one more thing? If your electric field is pointing towards the right hand side, which unit vector will be utilized? I cap, J cap, K cap. Which is the unit vector in the x-axis? I cap, correct. It will be positive I cap. Had it been left side, had we taken it on the left side, then it would have been negative. So the answer is now complete. If you know the unit vector, you have specified the direction I cap Newton per Coulomb. This is how we have to solve it. So quickly copy this solution. We'll just do the graph on it. Then I'll leave you guys today. Since many of you are studying since half an hour more than others. So I'll leave you after doing the graphs. So just note it down, text me done, then we'll begin with the graphs. 2 to 3 graphs I'll discuss. The Coulomb's law graph is also left and the electric field variation with the separation is also left. Okay, see, before seeing the variation of the graphs of electric field and electric force, let's just discuss the basics of the graph once. You all are already aware of the basics of the graph. Just we'll brush it up. See, the first kind of graph that you get mostly, if your dependent variable is directly proportional to your independent variable with the power 1. If y is proportional to x with the power 1. For example, if I say y is equal to 3x, so y is directly proportional to x. In such cases where you get a linear equation, see, the basics of graphs will be helpful till your end of the chapter. All of your chapters, this will be required. Whenever you get a linear equation, the graph you get is a straight line graph. Whenever you have such a relation, means linearly variation. So how to plot the graph? If this is your graph between y and x, this is a straight line that goes. Easy? First one. Second one, if somehow your y is proportional to x, but the power is not 1. Instead of the power, you're getting the power 2. Means now you don't have linear equations anymore. What kind of equations do you have? You have quadratic equations with you. Quadratic equations with you. If you are having quadratic equations, mean y is proportional to x, but the power is 2 right now. So the graph that will be plotted between x and y, see, you get basically a parabolic graph. A parabolic graph looks like this. Exponentially, it is increasing. The last graph that we'll be discussing. See, there are various kinds of graphs, but in your syllabus, for your syllabus, 3 kinds of graphs are sufficient. So the third one, if your y is not directly proportional to x, if somehow it is inversely proportional to x, let's say it is inversely proportional to 1 by x, or y is inversely proportional to 1 by x square, or y is inversely proportional to x cube, and so on. If you get such a case, then you get the graph as a hyperbola. Now see, how does the graph of hyperbola look like? This is your y-axis, this is your x-axis, this is your hyperbolic graph. So these are the 3 kinds of graphs that you get. Linear straight line graph or linear equation, you get quadratic equations graph as parabolic, and you get the hyperbola if it is inversely varying. Now see, now if we apply the same on Coulomb's law, Coulomb's law we discussed. What was Coulomb's law? Coulomb's law was, according to Coulomb's law, electric force, this was directly proportional to the product of magnitude of both the charges and inversely proportional to the square of them. This means what? This is F is equal to K Q square divided by R square if both the charges are identical. Now see, how does your force vary with R? Can anyone tell me, how is the force varying with R? Yes, class. Look at the formula. Yes, Reem, try.
It is inversely proportional.
Inversely proportional. Force is inversely proportional to R square. Force is inversely proportional to R square. We have seen this case. Rifat, you tell me what will be the nature of the graph. Will it be a straight line graph? Will it be a parabolic graph or a hyperbolic graph? It will be a hyperbolic graph. See, you get the straight line when? If force is directly proportional to the quantity. In this case, what? If force is inversely proportional to the separation. So it will be the third case. See, this case, y is inversely proportional to x cube. This case. So yes, Fahad, you are right. It will be a hyperbola in this manner. Force is inversely proportional to R square. If this is when, if I plot the graph between force versus R square, what if I plot the graph between force versus 1 by R square? See, your formula is K Q square by R square. I am plotting the graph between force versus 1 by r square. This time I am not considering r square. 1 by r square. See, F is what? F is 1 by r kq square. Can I write it in this manner? Now just replace force as y and replace 1 by r as x. This is the constant. How is the y varying with x? Directly or inversely? Yes, class?
Directly.
Directly. It means when we plot the graph between force versus 1 by r square, we get it as a straight line. Reason? Because force is inversely proportional to r square, but force is directly proportional to 1 by r square. Are you able to identify this difference? Difference between force versus r square and force versus 1 by r square.
Yes, ma'am.
This is 1 by r square. If anybody is having doubt in this part, because this is just the tricky part, rest of the parts are easier in the graph plotting. This is directly a straight line. Clear to all of you till here? Answer me with a yes or a no.
Ma'am, for the 1 by r square, can you please repeat?
For 1 by r square, I am repeating. See, Samya, the best way to plot the graphs, no, is what? Whatever is your one variable, take it as y, the other variable, automatically take it as x, and then see what is the relation. In the previous case, what happened? When we were plotting 1 by r, f by r square, let us take f as y, let us take r square as x. So what did the relation come out? F was kq square, means y is what? Y is kq square by x square. From this we could see y is inversely proportional to x square, so we got this hyperbolic graph. Now in the second part, Coulomb's law is what? Kq square by r square. Now if I separate 1 by r square, because I am plotting the graph between force and 1 by r square. So let us take force as y, let us take 1 by x r square as x. Now if you take it as this, f is equal to what? This is kq square by r square. Now what is 1 by r square that I have taken? 1 by r square is x. I'm writing x instead of 1 by r square. Others are kq square. And what is force? Force is y that I've taken. Now see how is y varying with x. Samya, directly or inversely?
Directly.
Directly. That's why we are taking. See, if you see this formula, kq by r square, only if you are considering force and the separation, then both are inversely proportional. But if you are considering force and 1 by r square, then force is directly proportional to 1 by r square. Is this clear now?
Yes, ma'am.
Similarly, if you plot it for electric field, see, electric field is what? Electric field is basically kq by r square, what we had seen. So electric field versus r square. What will be the nature of the graph? Yes. Electric field versus the separation. E versus r square. What will be the nature of the graph?
Inversely.
Inversely proportional. So it will be a hyperbolic graph. We'll get the graph in this manner. Clear to all of you?
Yes, ma'am.
Yes, ma'am.
Fahad, Rifat, and Yusuf, what about you? Okay, yes, Fahad. What about Yusuf and Rifat?
Yes, ma'am, it's clear.
Oh, all right, Rifat. Yusuf, respond. If it's clear to you, let us know. Just write it in the chat box. Till the time others quickly copy down this graph part. So this is the last portion for today. Now we'll then begin in the next class that we have. So just start noting it down and text me when you are done so that I'll know that you have written it down. And if you are having any doubts, you are welcome to ask me. You can unmute yourself or ask me, or you can type it in the chat box. After the class, you will be provided with the assignment. The assignment consists of only 3 to 4 questions hardly that are already discussed in class. The topics that have been covered. So you will be able to solve the assignment. Done, class?